Hello, this is Jeffrey Frankel with Solutions in Chemistry. Today I'm going to deal with questions in IB Paper 1 on the topic of acids and bases. You can do these questions in less than 30 seconds and get them right.
You're expected to know that HCl, hydrochloric acid, HNO3, nitric acid, and H2SO4, sulfuric acid, are strong acids. And there we go. So D is the answer. Less than 10 seconds you can do that. Anything else are clearly weak acids. Ethanoic acid, carbonic acid, and ethanoic acid. They are all weak acids. You're expected to know those three acids are strong acids. You're not expected to know the chemistry of perchloric acid or even the formula, HClO4. However, you are expected to know that if the examiner tells you an acid is a strong acid, then you're expected to know what that means. And clearly, HClO4 is completely dissociated in solution. That is what a strong acid is. HClO4 exists mainly as molecules in solution? No, that would mean it was a weak acid. Solution reacts only with strong bases. Well, weak acids and strong acids react with strong bases. Solution has a pH value greater than 7? No. Clearly you're expected to know that all acids have a pH less than 7. There are two ways an examiner can ask this question. He can say, an example of a strong acid solution is perchloric acid. Which statement is correct? In which case he is saying perchloric acid is a strong acid, even though you don't know anything about perchloric acid, you do know what a strong acid is. The other way of saying it is what they sometimes do with hydrobromic acid. They say hydrobromic acid has similar chemical properties to hydrochloric acid. You're not expected to know the chemistry of hydrobromic acid. However, as soon as they tell you it is similar to hydrochloric acid, then you simply look for, in this case, statements, or you look for chemical properties that would apply to hydrochloric acid. So those are the two ways they can bring into the question chemicals that you're not expected to know much about. Again, it's a question that you can do in less than 10 seconds. You are expected to know that strong acids and strong bases would have high conductivity. And there we go. HCl is a strong acid. It has the highest conductivity of all of these. Ammonia is a weak base, has a low conductivity. Ethanoic acid is a weak acid, has a low conductivity, and carbonic acid is a weak acid, has a low conductivity. The reason this has a high conductivity is because the HCl is totally dissociated into its ions. And it's the ions, H plus ion and Cl minus ion, that will conduct electricity. In the case of NH3 with water, 99% or more of it remains as NH3. The amount of ions present would be significantly less than 1%. And the same with ethanoic acid. The amount of ions present, the anion of ethanoate and hydrogen ion, would be significantly less than 1%. And in the case of carbonic acid, the ions present would be significantly less than 1%. So therefore, the solution that would have the highest concentration of ions would be the strong acid, HCl. Immediately you look at this, you realize HCl is not a weak acid. It's a strong acid. And therefore 3 cannot be in the answer. 3, no, 3, no, 3, no, must be A. Okay. And of course that is true. Ethanoic acid is a weak acid and carbonic acid is a weak acid. Like another question which should take you 10 seconds or less to deal with. This is another question about strong acids versus weak acids, and strong bases versus weak bases. The way I would look at this is if you arrange them in order of increasing pH and lowest pH first, I would first look at the lowest pH. What am I looking for? I'm looking for a strong acid. So go down here. Oh, look, that's that one. And I notice that's actually the only one that is the lowest pH. And then you look at this. That clearly is the highest pH because that's the strong base. And these two, well, that's an acid, a weak acid, and that's a weak base. So that is clearly the order. We've done that in less than 10 seconds. Now you may say, well, I didn't look at the lowest pH, I looked at the highest pH. Okay, so you look at the highest pH, potassium hydroxide, potassium hydroxide, potassium hydroxide. Okay, what's one of those three? Forget this one, because that's clearly wrong. And then you look through them individually, and you look at this end. I always look at the two extreme ends. You look at this end, and you'll find you'll get to B. Again, whichever way you start with the lowest pH or the highest pH, you will get to B within 10 seconds. And it's irrelevant what happens in the middle because there is only B there. So you don't even have to think about this, although it's clear that that's a weak acid. Therefore, it will have a lower pH than this, which is a weak base. Take advantage of these questions that take only 10 seconds, because by saving time on these simple ones, you have extra time to do on the more complicated questions in paper 1 afterwards. This could be nitric acid, which is a strong acid, or it could be hydrochloric acid, or it could be sulfuric acid. They're all strong acids. And we know that the most concentrated acid, W, will have the lowest pH, and we know that the least concentrated acid, the more dilute acid, will have the higher pH. So we're saying that in increasing order, it's W less than Y, which is less than X. W, Y, X, which is B. How long would that take? Maybe 10 or 15 seconds to do with that one. As with all of these questions where you expect to put them in an order, I look at the one extreme and the other extreme. Get those two right, and then the others will fit in the middle. Another question about acids, and this doesn't matter whether it's strong acid or weak acid. Acids react with ammonia solution to produce hydrogen gas. No, they do not. Just as a general rule, acids react with metals to produce hydrogen gas. Acids react with metals to produce hydrogen gas, not with anything else. Just remember that. Okay, acids react with metal oxides to produce oxygen gas? No. Acids rarely react with anything to produce oxygen gas. Rarely. Acids react with reactive metals to produce hydrogen gas and a salt. Now that is true. That is definitely true. Acids react with metal carbonates to produce hydrogen gas. No, they don't. No, they don't. Acids react with metal carbonates to produce carbon dioxide. C is the correct answer. Here you're expected to look at what is not correct. Hydrochloric acid can have a pH value of 0. Yes, it can. Actually, it can. I know it's strange, but it can if it's very concentrated. pH paper contains more than one indicator. General, yes, they do contain more than one indicator. The pH value of an acidic solution decreases when water is added to it? No. The pH value of an acidic solution increases when water is added to it. That's clearly not correct. Dilute hydrochloric acid conducts electricity. Definitely true. So, another question, which, reading through it quickly, you can see which one is correct and which one is not correct. This one is probably the one that would cause most problems to people. Because of the nature of pH, you always assume it goes from 1 to 14. But in fact, it can be 0 and it can even be negative for an extremely concentrated solution of an acid, just by the nature of pH. As I said before, hydrochloric acid is a strong acid. All other acids are weak, unless you're told something different by the examiner. So, you can assume methanoic acid is a weak acid. So let's go through this. HCl dissociates more than methanoic acid? Yes, it does, because HCl is a strong acid, methanoic acid is the weak acid. HCl is a better electrical conductor? Yes, for the same reason. HCl is a strong acid. HCl is completely dissociated in water, whereas the methanoic acid is not. It's only partially dissociated, so HCl is a better electrical conductor. HCl will neutralize more sodium hydroxide. No, that's not true. They will neutralize the same amount. So 3 is wrong. Don't go for there, not there, not there, not there. A is the answer. And 1 and 2 are the only 2 that are correct. In the IB, you're expected only to deal with monoprotic acids when it comes to distinguishing between strong and weak. So they're really asking you, what's the difference between a strong acid and a weak acid? And you know that a strong acid is completely dissociated into ions. So whatever is the concentration of the strong acid, that is the concentration of the hydrogen ions. Whereas in the case of a weak acid, the weak acid is not completely dissociated. And therefore, if you've got a particular concentration of weak acid, you only have an extremely small concentration, 1% or less, of hydrogen ion. So it says, add magnesium to each solution and measure the rate of the formation of gas bubbles. Clearly, with a high concentration of hydrogen ions, that will have a higher rate of formation than an acid with a low concentration. So yes, one can distinguish between a strong and a weak acid. Add aqueous sodium hydroxide to each solution and measure the temperature change. Yes, when you add aqueous sodium hydroxide, it reacts with the hydrogen ions, and if there's a higher concentration of hydrogen ions in strong acids, then that will give you a larger temperature change than in the case of the weak acid. So we now have 1 and 2 can distinguish. Use each solution in a circuit with a battery and lamp and see how bright the lamp glows. A strong acid has more ions than a weak acid, and therefore a solution with a strong acid, the lamp will glow brighter than in the case of a weak acid. So the answer is clearly 1, 2 and 3. All 3 are methods of distinguishing between strong and weak acids. In this case, you have 2 acids, one a strong acid, hydrochloric acid, the other a weak acid, ethanoic acid, and you're expected to find out which method could not be used to tell them apart. Compare electrical conductivity. Clearly, that can be used to tell them apart because electrical conductivity will be dependent on the ions present. There are a higher concentration of ions in hydrochloric acid than ethanoic acid. Therefore, electrical conductivity can distinguish between strong acid and weak acid. Compare the reading they give on a pH meter. Again, a strong acid will have a different pH, a lower pH, than a weak acid at the same concentration. Comparing the volume of sodium hydroxide required for neutralization. Now here we have a method which cannot be used to tell them apart because when it comes to neutralization, you get 1 mole of sodium hydroxide will react with 1 mole of hydrochloric acid, and 1 mole of sodium hydroxide will react with 1 mole of ethanoic acid. The rate at which they happen may be different. The heat involved may be different, but the volume of sodium hydroxide is the same for both a strong acid and a weak acid. D. Comparing the rate of reaction with calcium carbonate. Obviously, the rate of reaction with calcium carbonate will be different from a strong acid than from a weak acid. So the answer is C. You cannot use the volume of sodium hydroxide that is required for neutralization as a method of distinguishing. Thank you. Another question about a strong acid and a weak acid. And in this case, they're the same concentration and they're reacting with calcium carbonate in separate containers. Which statement is correct? Okay, there are some things that will be the same for hydrochloric acid and ethanoic acid, and some things that will be different. Ethanoic acid reacted slower because it has a lower pH. Well, yes, it does react slower, but it actually has a higher pH than that. So that's not correct. A smaller volume of CO2 was produced by ethanoic acid than with HCl. No, the same volume of CO2 will be produced. Now, it may take longer to do it with methanoic acid, but it's the same volume. A greater volume of CO2 is produced? No. Now, this must mean that the same volume of CO2 is produced with both. Yes, the same volume is produced. The difference between strong acid and weak acid is due to the amount of dissociation. In the case of hydrochloric acid, it is completely dissociated, and therefore it will react faster than ethanoic acid, which is not completely dissociated. From the point of view of general chemistry, it does react with the same chemicals. Both hydrochloric acid and ethanoic acid will react with calcium carbonate to produce the same amount of carbon dioxide. However, because the hydrogen ion concentration in HCl is greater than in ethanoic acid, the rate of production would be greater with HCl. So it's important to remember it's the same volume of carbon dioxide is produced. And if it was anything else, a metal, it would be the same volume of hydrogen would be produced as well. This is one of those questions where is it part of periodicity, trends in the period 3, or is it part of acid base? The examiners have total freedom to ask the question, and you don't know which topic it comes in. As far as I'm concerned, the sodium chloride is the only one that is neutral in water. This would give an acid reaction in water, and that would give an acid reaction in water. One only is the answer. You simply have to remember that aluminium chloride gives an acid reaction when added to water, and all the non-metal chlorides, whether that's HCl, SCl2, PCl5, there are other sulfur chlorides, phosphorus chlorides, all the nitrogen chlorides, etc., etc. They will all give an acid reaction with water. As with the previous question, this can come in two different topics. Is it a trend within period 3, or is it in acid base?
If the examiner tells you that something is amphoteric, then that means it can show acidic behavior in the presence of strong alkalis, and it can show alkaline behavior in the presence of acids.
And what you do have to remember, the one thing that aluminium oxide does not dissolve in water. It can show acidic behavior in the presence of strong alkalis. It dissolves in strong alkalis. You're expected also to know that it dissolves in strong acids, and you're expected to know that it does not dissolve in water. So 3 is wrong. That 3 is wrong, 3 is wrong, 3 is wrong. Only A is correct. 1 and 2.
If you found this YouTube video helpful, please subscribe to my channel, Solutions in Chemistry, and look at my other videos. Thank you.